Good evening, everyone. Welcome to the Modern Full Stack Web Development Essentials AI and Serverless Revolution class. I'm happy to welcome you all today. We're excited to have you join us for this insightful session. I would now like to introduce our trainer, Sir Deepan, who will be leading today's class. Sir Deepan, over to you.
Thanks, Gigi, and thanks everyone for joining in. Very good evening, everyone. My name is Deepan Chakravarti. I'm a trainer working in Garanto. Yeah, I'm a trainer working in Garanto. I'm also a lead software engineer, managing the different softwares that we are running in Garanto. Um, I have over 10 years of experience in software development, and especially I was, worked majorly with the ERP suite like CRM, LMS, ERP solutions, and I also trained over 500 BFSI professionals across different financial institutions like Citibank, JPMC. And today I'm here to give you an overview on different skills and technology that are associated with a modern full stack web development. Right. No, so this is what we are going to do today in the next 1 hour. So this is about modern full stack web application development essentials, and along with these essentials, we are going to say how this plays together in the current trend of AI. Right. So right now the buzzword is AI. In spite of knowing all these technologies, how these technologies and then these tools skills are going to be relevant or play together with the AI, right? And along with the AI, we are going to see one more critical skill that everyone must be accustomed with is something called serverless, right? So how are we going to manage deployment or other the deployment of modern applications in the modern world using something called serverless technology, right? So this is primarily about full stack web development essentials along with AI and then serverless. Is that fine? Any queries here before we proceed into the next steps?
No, thank you.
Yeah, great. Like I mentioned, um, so this is about uncovering all the tools and technology related to full stack web development, right? So what exactly it is? So right now, as a beginner, we might have heard different tools and technology. Like someone might have heard Angular, or someone might have heard terms React several times. We in the in the more often than not, we might be hearing something called microservice architectures. We might be hearing something called Kafka. We might be hearing something called RabbitMQ, right? So we hear something called Express, all those stuffs. We heard something called JWT, OAuth, something like that. So we know all these things, but the thing is that what are the role played by these technologies in a web application? So that is what we are going to see today. So this is about uncovering all these essentials, and which means uncovering all the tools, technologies, framework, libraries, whatever it is, and then what are the key roles played by these different tool suites, right? In a web development, in a full stack web development. So that is what it is, right? So how this is going to help us? This 1 hour is going to help us. Is this will help us in building a clean roadmap for our future learning, right? So in case if you want to pursue the track of full stack web development, so this understanding, basic understanding on different tools and their roles will help us in creating a clear roadmap. Right. Right. So this is what is the objective. So we're going to decode different layers of full stack web applications. So for us to know the essentials, we need to decode a full stack web application. Right. So if you take full stack web application, it is being built with different uh, layers, right? So it has different things, like it has something called front end, back end, it has something called API, stuff like that, right? So we are going to decode the layer of a full stack web application to understand the essentials, right, that is required to build such application, right? So so with that decoding, we are going to, what are the key takeaways that we are going to take is the key technology and tools used in each layer, and then along with it we are going to see how AI and serverless plays a role in it in the modern development. And then so this will help us in identifying the FSD skills, right? And then most importantly, how these FSD skills are going to be helpful for us in working with AI projects, right? So right now it is more about building AI agents, applied AI, stuff like that. So how these skills, or these skills even now it is going to be relevant even then, even the invent of AI as well. So that is one more aspect that we are going to justify. So how these FSC skills are going to helpful for us to work with AI projects. And then like I mentioned, this basically help us in building a roadmap for learning or rather pursuing the full stack track, right? Right now, what is a full stack app? Like I mentioned, so this includes everything in an app. So when we say full stack app, this includes whatever that is involved in a full stack applications, right? So right from front end, back end, APIs, databases where we store our data, and how it is getting deployed, process, how it is getting tested, what are the automation involved in it, right? How the communication happens, whether it is synchronous or asynchronous. If it is synchronous, how the synchronous communication takes place, what are the key considerations that are associated with it, and if it is asynchronous, what are the tools associated with it? Like we have something called Kafka, right? AMPQ, right? Asynchronous message queuing protocol, and then we have something called socket, something like that, right? So when I say full stack app, so this includes everything that included in building and managing the full stack applications, right? So right from client side and to the server side, whatever that is makes up a full stack applications, that is what we call as a full stack app, right? So basically, a full stack developer will be involved in all this aspect of the full stack development, right? Basically, he'll be having the ability to deal with the full stack front end part of it. He'll be having the ability to deal with the server side. He'll be having the ability to test the build test script for testing that full stack application. He'll be able to deploy it. He'll be able to monitor it, like observability part. He'll be able to manage the communications, all aspect of it, right? So when it comes to full stack application, so this is a common architectural pattern, right? I believe most of us might have been might have come across some of these architectural patterns, right? To start with, the simplest architectural pattern that we will be follow is something called monolith, right? So monolith, we call it as a monolithic application, and then we have something called microservices, and then we have something called serverless architecture pattern, right? So in monolith, everything is built in a single unit, right? So like I mentioned, the entire full stack, all the full stack things will be bundled as a single unit. So the same application or the same distributable will be having its front end, back end, and whatever it is, everything, database logic, whatever it is, everything will be built as a single unit. Whereas in microservices, so the application will be built as a separate application, small applications. We call them as microservices, where it is bounded with the boundary context, right? So whereas in monolith we deal in terms of domain, right? So in monolith we deal in terms of domain. We don't actually deal much in terms of subdomains, right? So for instance, if you take a e-commerce as a domain, we built a e-commerce app, that's it. So we don't worry about what are the individual subdomains of that e-commerce. For instance, within an e-commerce we have subdomains like users, we have notifications, we need to manage the products, we need to manage the transactions, stuff like that. So these are the different subdomains that forms the e-commerce domain. So in a monolith, we don't actually deal in terms of subdomain. So we actually deal in terms of domain as an entire domain. What are the different services that I need to provide, and then I'll put it all together as a single unit. So that is how we deal in monolith. Whereas in microservices, in order to have better scalability and manageability, right? So you can think how complex it would be if I have to if I don't have a clear classification between the subdomains, how coupled the services will be and how difficult it will be managed, right? So for instance, if I want to update a particular code related to transaction, it might be coupled with a code that is related to product, right? So if I'm doing some changes, it might it might also affect the product code as well, right? A code that is related to product as well, right? So this is in terms of logic, right? So this will This will apply to logic, and this will apply to database schema as well, right? So for instance, I want to update a schema related to product. In doing so, I might also disturb the schema related to other transactions, which has nothing to do with the product. So here the challenge is the management and then the scalability. So how I am going to manage the application, how I am going to scale the application. So that is the key consideration in monolith, and hence what we are doing in microservices is that instead of handling the application at the domain level, we are actually managing the application at the subdomain level, right? So we create clear boundary context, and then we create applications for individual subdomains, right? Meaning we create multiple small applications that make up a single application. So we call that we call that particular application that handles a single subdomain as a microservices, right? It will be having all the key characteristics of a normal monolith application, right? So common architectural patterns, monolith is simple. Whatever that I want to do, I'll be coding it in coding, and then I'll be developing it as single unit, and then I'll be distributing it. Whereas in microservices, I'll be building it as separate applications, and then I'll deploy them. So this is for improved scalability and then improved manageability, and then serverless. In serverless, I don't worry about the infrastructure. I simply write my functions. So the infrastructure will be provided by the service provider, typically the cloud service providers. Like we have Lambda from AWS, we have Google functions, we have Vercel functions. So we have a lot of serverless platforms that are there. So they will manage the infrastructure. We don't worry about what server it is using, what platform it is using. We simply need to write the functions, and then everything else will be taken care by the cloud provider themselves, right? So a much more higher uh, higher way, I know high level way in way which we deal with the application development, right? So very high level way in which we deal with application development, where it abstract everything, all the abstract all the domain considerations, or rather the infrastructure consideration, to be precise, right?
Can we ask questions now or later, sir?
Yeah, go ahead. Yes.
Yeah. So specifically, what are the advantages of these three types, and when we naturally go for this deployment, either monolith or microservices or serverless?
Yeah, so monolith is very straightforward. It doesn't apply for all the complex business problem. So if your requirement is simple, and then if you don't have any complex requirements in terms of management, then we'll go with monolith. It's a typical approach, plain old approach. But then if the application is big, a monolithic application, we cannot able to manage, right? For instance, a e-commerce application, it has different things to manage, right? So for manageability, we go for microservices, because in terms of when it comes to e-commerce, e-commerce is an enterprise application, right? So when we say enterprise, it is a big application. So it has a lot of things that it has to manage. For instance, it has to manage the core functional logic, right? And it has a lot of non-functional aspect as well. For instance, we need to manage the security, we need to manage the transaction, we need to manage the messaging. So there are a lot of stuff that we need to manage. So what happens in a big application, if it is built as a monolith, is that the application will be very fragile, or rather rigid. Um, Rigid in the sense, we tend to make the application as a tightly coupled application. As we go on and build the application, when it is small, it will be very easy to manage. In a typical enterprise application, as we go on and build the application continuously, the application will grow bigger and bigger. So when the application is smaller, it will be easy to manage, and when the application is growing bigger, it will be difficult to manage, right? So that is where we need to uh, we go for microservices, where instead of building the application as a single application, we build the application as a multiple small application. So we are scaling the application here horizontally. So meaning if the application is enterprise, if the application has a potential to grow big, then we go for microservice. Right. So typically all the enterprise level application will go with the microservice architecture. But right now it is not actually a rule for us to go with microservice. Microservices also has its own challenges. If the application has the potential to grow big, a typical enterprise application, then the best way to deal with this microservices, because we cannot make the, if the application is monolith, uh, we cannot manage it with a single team. So we need to have multiple teams to manage it. And how do we run multiple teams parallelly? If it is single application, we cannot make the multiple teams to deal with that single application. So if it is microservices, we can run multiple teams parallelly, where one team will manage one microservice, the other team will manage another microservices, and all these things will happen parallelly. You understand, right, Suryanarayanan?
Yeah, thank you, sir. Thank you.
Yeah, great. Yeah.
So just one more question, Deepan. Microservices architecture and something called SOA, right? Service oriented architecture. Are they same or are they different?
No, they are different. Service oriented architecture is based on a different protocol. So microservices is just a pattern. It
Pattern.
doesn't, it has nothing to do with any protocol. So SEO is primarily based on something called a different a protocol, right? It works based on protocols, whereas microservices is just a pattern.
Okay.
Yeah.
Thank you. Yeah.
Right. So now even with monolith or even with microservices, we still need to manage the deployments. So we still need to manage how to deploy, right? So what server that I need to use, what typically I need to worry about infrastructure, right? So whereas this serverless thing that completely abstract away all these things, like the infrastructure, how I am going to deploy all these things, it will be completely abstracted by serverless. So here I'll only worry about functions. Right, I simply write my functions and then the application will work. So the underlying infrastructure is going to be managed by the cloud provider. Right. So this is a typical architecture of a monolith. So we have a client will communicate with an application. That application will have everything. Right. So primarily it has three foundation layers. The UI, the front end layer, we call it as a UI layer. And then the back end layer, we call it as a business logic layer. That is where the application's business logic will resides in. And then the data access layer will have the logic for accessing the database, and then ultimately the database will be there where the actual data will be there. So all these logics will be put together as a single unit. So there will not be any primary classification between the logic itself. Right. For instance, if you see the business logic here, this is an example. Here we are taking a e-commerce as an example, e-commerce app as an example. As part of e-commerce, we need to manage user, product, order, and payment. So here we don't think in terms of user as a separate service, or product as a separate service, or order as a separate service, or payment as a separate service. I simply write my functions. Right. I'll simply write my functions, and then all these functions are coupled together. There is no clear separation. For instance, if I want to make change in a product, and even if it has nothing to do with user or order or payment, I need to compile and build the entire application all together every time, right? So this is a primary architecture. This is a foundational architecture. Very easy to build. I can simply, very straightforward. I can suitable for smaller applications, right? As the application grows, then it will be difficult, right? So that is where we are going for a something called microservice architecture, where instead of building an application as a single application, here we build the application as multiple applications. Right, here we build, here even we are doing monolith, but this monolith application will not cover all the entire domain. It will only cover a particular subdomain by forming a clear boundary context, right? So if you take e-commerce as a domain, what we'll do here is that we create a clear boundary context between these subdomains. So within e-commerce, we have user as a subdomain, product as a subdomain, order as a subdomain. So between these subdomains, what we'll do is we will create a clear boundary context, and then for each boundary context, we create one small application, right? And then so basically, microservices is about how we are decomposing a monolith into multiple application, right? So it is about decomposing a monolith into multiple application, and how are we making these applications to communicate with each other in order to uh, uh, achieve the functionality of a application, right? So that is what it is. So instead of building it as a single application, what we are doing here is we are decomposing that application into multiple applications, and these multiple applications are small applications since they are dealing with a particular subdomain of the entire domain. So we're calling that small applications. It has all the key characteristics of a typical monolith application, but it deals only with a subdomain, right? So we're calling it as a microservices, very independently deployable, independently manageable, right? And so it is about creating multiple applications, multiple independent microservices, and then making this small applications to communicate with each other, thereby achieving the application functionality, right? So that is what it is. Alright, so this is monolith, a single application. Instead of building a single application, here we are building multiple application, and then that multiple application, how are we going to make communication with each other, right?
So I have
Yeah.
a question here. So
Yeah.
each of these are like behaving like a small application, right? And you
Yes.
said each one having the same characteristics of a monolithic application.
Yeah.
So does it mean that, for example, user service, right? Does it
Yeah.
have its own front end? That it has its own business logic, and it has
Yes.
got its own database inside, is it?
Yes.
Within
Yes.
that?
Exactly.
Our database is
Exactly.
common.
No, that depend upon our requirement. If you want to have a single database, we can have, or if you want to have a separate database for individual applications, we can have. So that is the idea. So we call it as polyglot persistent. For instance, this user service, for instance, this is about managing the user credentials. So we need to have a strong schema. So probably I'll go with MySQL. For
Okay.
instance, product service where I don't need to worry about the data security. I simply need to have my schema more flexible, because over the period the product will be having more fields, right?
Diversity,
So it will be
okay.
having diverse fields. So in that case I cannot go with a rigid schema. So here I need a flexible schema. So what database can I use? I can go with a NoSQL database, like the one that has the no schema or flexible schema, like MongoDB or DynamoDB, something like that.
Okay.
Right. So with microservices, like I mentioned, since they are independent monolith applications, so depending upon our requirement, either we can make these applications to have a same database or different database. Right.
Okay.
So we call it as polyglot persistence. And then, so like the way I mentioned, so polyglot or single database instance, and then here I'm saying something called API gateway, and then I mentioned something about this service communications, how the service is going to communicate with each other, whether to synchronous or asynchronous, and how these services are going to identify themselves. Like a registry kind of thing, and how the individual instance of the applications are going to be managed. We call them as load balancing, right? On how the we are going to manage the fault. For instance, if one service fails, here we are speaking about service communication. For instance, if the service fails, and the communication will also fail, and thereby the application will also fail. So I need to have some fault tolerant. So these are the different patterns or solutions of microservice architecture. So when we say microservice architecture, it is a combination of multiple design patterns. When I say design patterns, they are all solutions. For instance, like you mentioned, how do I manage the diversity of data? So we had polyglot persistent as a solution, right? And then how do I manage security of multiple applications? So we have this API gateway as a solution, right? So microservice architecture is about a combination of multiple design patterns, right? Right. Right now, if you can see here, right. So if you can see here, we have different services. So this is again a simple architecture, something like what we are having in our slide. So we have different services, and then we have an API gateway that acts as a entry point for all the services. So if you have any security thing that we want to implement, then we have one more service, right? So these are the functional services, these are the core functional services, and this is a secondary functional services, because this is not directly related to what we are delivering to the client. So these are things that we are delivering to the client, and these are the secondary thing that are going to be used to manage these core services. So we call it as secondary functionalities, and all the secondary functionalities will be forming their own services, right? And we can see it uses different databases. So this is the simplest microservice architecture, microservice application that we can see. And then going forward, we can see much more complex diagrams. So where you can see registry, load balancers, you can even have multiple API gateways, right? You can have multiple API gateways. So this is about there is something called separation of concern. So that is a key thing that drives this entire decomposition. So when I say separation of concern, an application that we are building that needs to handle only a particular responsibility, right? Application has to manage a particular responsibility. So if it has two or more responsibility, then we need to split the application, right? So that is what it is. For instance, if I'm building this as a monolith, then the application will have multiple responsibility. It will have to handle both catalog and then shopping, right? It will need to handle both user and product. And then what we are doing, we are decomposing the application into two instead of one. Thereby one will handle one responsibility, which is user, the other will handle the other responsibility, which is product. So this is for the secondary requirement as well, right? So I have security, I need to handle security, and then I need to handle transactions, or I need to handle logging. For instance, there is logging and security. So this logging will apply for all the services. The security will apply for all the services. How I'm going to implement? So I need a API gateway, right? I'm having an API gateway. So here I can handle all the security thing, and then all the logging as well, for instance. And then if that is the case, this API gateway will have two responsibilities. It has to handle both the security, and then it will also handle the logging as well. So in that case, I can have two gateways, where in one gateway that will handle only security, the other gateway will handle only the logging, right? So the key thing, how are we going to have multiple services here? The key thing that drives here is the separation of concern, right? If you think in terms of single responsibility, then we'll have a clear idea on how we are going to decompose into multiple applications. We able to understand this, right?
Yeah.
Right. So with this architectures, so what we can understand here, what we are trying to understand is that the different layers of a full stack application, right? So the application will be having something called front end. Whatever the user sees, that forms the front end, right? So front end is how the user will get to interact with the application, right? So the front end, and then the back end that contains the server logic, and then how the front end is going to speak with the back end, right? So there we have something called APIs. APIs is how we make the front end to communicate with the back end, or the applications. In a typical microservice architecture, we have multiple applications. How are we going to make the applications to speak with each other is through APIs, right? And how are we going to handle the data that is going to be handled in the applications? I mean, data of the applications it forms the database layer. And how are we going to manage the source code? We have something called source code management. How do we going to manage the operations? We see DevOps, and then deployment and security. So these are the different aspect of a full stack application. Now, if I am a learner, if I want to pursue a full stack track, then what I need to do, I need to learn all the tools and technology related to a front end layer, all the tools and technology related to a back end layer, API layer. What are the two different tools and technology? So I might be hearing something called REST, GraphQL, Socket, right? All those stuffs. API layer, Kafka, RabbitMQ, stuff like that. All those things will fall under API layer. Under database, all those database things like SQL, NoSQL, MongoDB, DynamyDB, cloud databases. All those things will fall under database layer. Git, GitLab, GitHub, right? All those stuffs. CI/CD, Agile, right? All those things will fall under SCM and DevOps. And then under deployment and security, right? So now this is about how the application is going to deploy it, right? So this is where we have serverless, Docker, Kubernetes, right? JWT, OAuth, all those things will fall under deployment and security, right? So this primarily classifies all the aspects that are involved in a full stack application, right? Right. So in terms of front end layer, what is a front end? So everything the user sees and interact with the browser, it forms a front end, right? So whatever the client is able to see, front end is how we are making the client to interact with our application, right? So whatever the client sees in our application is becomes the front end, right? So what are the core concepts involved here? So here the core concepts involved here is the UI UX principle, semantic HTML markup, which is semantic tag, CSS selector and specificity, DOM manipulation, and then responsive layout. So typically this is about to start with the front end skill. It is about building a simple responsive multi-column layout web page using the core technology of web, right? So this is a foundational web skill, right? So this involves HTML, CSS, JavaScript, and TypeScript, right? So if one has to start the journey of full stack journey, then we need to start with the front end layer, and in terms of front end layer, and the very basics will be the core web technology like HTML, CSS, and JavaScript. So HTML is how we define the structure of the UI. CSS is how we make the structure more presentable. Right? For instance, if you can see here, we have the content, and then here it is more presentable. For instance, here we have the header, we have a footer, we have navigation icons. Here I have text, here I have images, right? And then all this tech, in addition to that, right? In addition to that, this is rightly aligned, styled. For instance, this heading is much more bigger, and it is in different color. This has a different size, and this is aligned in center. And then here I have three cards. Meaning you have three columns, and in one column I have a heading and a paragraph, and in another column I have a heading and a paragraph, something like that. All right. So this basic structure is provided by right. Right. So I've deleted this style. Right. I've deleted this style. Now you can see here. This is I have this basic things, but it is not displayed properly. I'm deleting all the CSS things. Right. Now as I do, we can see here the content is there, but then the content is not presentable. Right. So the reason being the CSS not is there. All right. So HTML gives the primary structure.
What is that full form of CSS? You said
Cascading
Um,
style sheet.
cascading
Style sheet. Yeah.
Okay.
Yeah, cascading style sheet, right? Hypertext HTML stands for hypertext markup language. CSS stands for cascading style sheet. JavaScript and then TypeScript. So HTML is how we give the structure. For instance, right? Right. So now what we are seeing here is the HTML, right? So this is how this gives us a programming model for which we can define our information. So I can tell this is going to be a heading, this is going to be a paragraph, this is an image. So how do I structure my content is through HTML. So HTML
Okay.
provides HTML tags. This is how I can structure my content. But this doesn't makes our content more presentable. So in order to make my content more presentable, for instance, this text has to be bigger. I need to set size, I need to set different size, and then I need to align it. So these styles are provided by CSS. Right. Right. And how do I make the content interactive? For instance, if I click, it has to interact. So I should be able to interact. For instance, here I'll see here I'm interacting with my UI. For instance, if I click, it moves to a previous slide, and here I click, here it's moves to a next slide. So here it is I'm able to interact with the content. How this is happening? It is because of the logic that I've written. If I click, I'm that logic that takes my current view to a previous view is getting executed. And how I'm able to build this logic is through something called JavaScript. So JavaScript is a programming language, primarily runs in the browser, right? So now this is how I write logic for to make the UI more interactive. Right. So HTML is about structure, CSS is about styling, JavaScript is about the interactive. This is how I write logic to make the content interactive. Right. So these are the core web technology. And if someone has to start their journey in full stack web development, and these are the three things that we need to begin with. Right. Right. So once we are, once the core technology is done, and what is next? The next thing is we should be able to do something called responsive web design. Right. Again, this is also the front end layer. In front end, once we have done with the core logic, the next thing that we need to be able to do is responsive web design. So now this is about making the content seamless across different screen sizes. For instance, so here the content is more presentable in a medium screen. Whether the content will be behave in a similar fashion in a mobile device or in a tablet or in a different device of different size, right? That is where we need to address something called responsiveness of a web design. So if a page is not responsive, it will not display properly across all devices, right? So for instance, I reduce a screen size. Right, if you can see here, the content is getting realigned. So meaning this content is responsive, right? So this content is responsive. So for smaller devices, you can see here, I have this heading here, I have this paragraph here, whereas I have these two columns which was occupying a same row. Now it is occupying a same column, right? So previously in a bigger device, I have two columns. Uh, I have two cards. They are occupying a same row, right? Uh, Suitable for a wider width. Now I reduce the width of the screen size. Now you can see here one card is in the first row and the second card is in the second row. So meaning the content is aligned according to the screen sizes. So this is called responsive web design, right? So if the page is responsive, it will be displayed in all devices of different sizes. If page is not responsive, it will not be it will not be displayed properly in different devices, right? So after the core the web skill, the primary skill that one needs to get is responsive web design, right? So what are the key concepts in responsive web design? It is called mobile first approach. So we need to do our design for the smallest screen possible, and then we need to scale up, right? And then there is something called fluid grids, right? So we need to use relative units instead of absolute units. So if I'm using absolute units, I kind of writing it in a stone, right? So meaning it will work only in that particular instance, right? If the platform changes or if the device changes, it will not work for the other devices. So we need to use something called relative units like percentage instead of pixels, right? So for instance, instead of saying 5 pixel, if I say 5 percentage, right? So that for that 5 pixel might be visible properly in a mobile device or a larger device. In a mobile device, that 5 pixel will not be visible properly. It will be very small. So instead of going with a pixel, which is absolute unit, I need to go with a relative unit like percentage. If I say percentage, 5 percentage in a for a bigger screen, the 5 percentage is bigger, and then even for a smaller device, the 5% will be bigger enough to be visible in a small device as well, right? So how do we go with fluid grids? By using relative units and then flexible images, and then how do we write conditions, right? For instance, you can see here different styles will be applied for different screen widths, right? So we are speaking about CSS, and I mentioned something called cascading style sheet. What does that mean? A particular content will be having multiple styles written for it, right? Multiple style written for it, coming from multiple style files, right? And when it is getting rendered in the browser will actually cascade all the styles based on the priority, and then it will apply one style at a time. So it will actually kind of cascading all the styles. So hence it is called cascading style sheet based on the priority, right? So what particular style it has to choose at a particular instance, that is what is called media query, right? That is called media applying css based on device characteristics like width and height. So if I'm going to have a only single style for this particular thing, it is not going to work across multiple devices. So for a bigger device, this should have one style. For a smaller device, this should have another style. That is how it has to work, right? So that is a primary thing. For instance, if you go to any other size screen, for instance, I'll go to Amazon. Right. Now we could see here for bigger screens, this search bar is at the bottom, right? And for smaller screens, it is getting moved to the top, right? It is getting moved to the top, and then this is having a different style. So this is arranged in a circular fashion. These languages, and for a bigger device, and for smaller device, if you could see here, it is turning into a list, right? So it has three columns, and here I have one list, and then here I have one list, and then here I have one list. What does it mean? Here one style is getting applied depending upon the screen width. Here one particular style is getting applied, CSS style is getting applied. The moment the screen width changes, another CSS style is getting applied. Right. So how does it choose the CSS style? Based on the rule, right? For bigger screen, it chooses one CSS style, and for smaller screen, it chooses one CSS style. So that is why the search bar, which is at the bottom for a bigger screen, it moved to the top because of a different style, and that is why this the languages that is appearing differently for a bigger screen, it is getting displayed as a list for a smaller screen. So a different CSS style is getting applied. So applying different CSS style based on rule, applying different CSS rule based on the device characteristics, right? Based on different rules is what we call media query. And then this media query is a key thing that we need to learn in terms of responsive web design, right? So now these are the primary concepts, and how are we going to implement it? Are we going to implement it with the primary concepts, or is there any other frameworks or library or template that is going to make the things pretty easy, right? And that is where we have these additional concepts: CSS, Flexbox, and Grid. We have something frameworks, CSS frameworks. We call it as Bootstrap, which we might have heard. Uh, Many a time we have something called Bootstrap and Tailwind CSS, and tools like Figma, and then browser tools, right? So all these things is will make the development much more simpler and easier, right? Meaning with this core technology we'll be able to build any UI, but if the UI is complex, it will be a challenging thing for us to handle it, right? So there are a lot of things that we need to manage, non-secondary things, non-functional things that we need to manage, right? So what do? We take help from this CSS frameworks, right? So this provides responsive elements, right? This provides responsive elements. For instance, I go to Bootstrap. Right, I go to Bootstrap. Like I mentioned, now this is a responsive framework. Right, so if I want to build a responsive website, then I can choose to go with Bootstrap as a framework. Right, now if you can see under components, it has different responsive components. I go to the accordion. Right, I want to use accordion, so this is what we call it as an accordion. Right, so by default we have the description, content heading, and the description. The description will be hidden behind a collapse button. Right, if I click the button it will show up, and then if I click the button it will collapse. Right, so this is what we call accordion. Now without Bootstrap, if I want to build this accordion, then it will be a challenging task. Right, I need to directly deal with low level functions or rules, CSS rules. Right, I need to write my JavaScript functions, right, plain JavaScript functions. So this is going to take a lot of time for me. Right, so and that is where framework like Bootstrap or Tailwind is going to help us with predefined, that comes with predefined responsive components that I can use directly in my web page. For instance, I want to use a carousel, right? I want to use a carousel, something like this. If I want to build a carousel like this with plain JavaScript and CSS, it will be a challenging task. Instead what I can do, I can choose to use a carousel that is coming from Bootstrap, right? And by default, whatever things that we are using from Bootstrap or Tailwind, it is going to be responsive, right? So hence they are called responsive frameworks, right? So this is where framework like Bootstrap or Tailwind CSS will come into picture, right? And on top of the core web skills like HTML, CSS, and JavaScript, uh, the other additional skill that we can choose to go with this Tailwind CSS and Bootstrap, right? Right. And what is next? So core web skills, responsive web design, and what is next in terms of uh, building a UI, right? How about building a much more interactive UI, right? Seamless UI. For instance, this web page, this is a web page, right? This is a normal web page, right? And again, this is also a normal web page. So this is about simply sharing the content, right? This is about simply sharing the content. So I'll choose a particular topic, right? I'll be able to explore the content, right? Right. On the other hand, I have this Gmail app. This this is not similar to this Wikipedia web page. So this is like a dashboard, right? We can see here I have different options here. I choose, and accordingly, right, right. You can see here as I work through this application, the page is not reloading, right? So this typically give a feel of a native application, like the native application that we used to install in our machines, like Word applications, mail, for instance. Again, right, so if you can see, this pretty much looks like a Outlook app that we used to install in our native application, right? So this is also a web UI, but this is much more seamless, much more interactive, right? And then it is not reloading, right? It is not reloading, right? It's completely different from a conventional uh, website. So this is what we call single page applications, right? This is called single page applications. So this is for creating fast, fluid, and app like web experiences. So these are in fact applications, right? So this is what we called as a website, right? This is what we call as a websites like Wikipedia, and this is primarily about content sharing. They are actually the websites, whereas this Outlook that we are accessing in our browser, or rather the Gmail that we are accessing in our browser, Google Sheets, where we are working like an Excel sheets, right? Google Docs, where we type our documents, where we manage our documents, they are all web apps, right? So what it takes to build a app like UI using the web technology, the concept is called single page applications. So single page application is the concept. It's how we build fast, fluid, and app like applications using the web technology, right? So the key concept is one HTML, client side routing, component based UI, API driven, and then state management, right? So these are the key concepts of single page applications. So the idea is to build applications, web applications, not just websites. So these web applications doesn't reload. It will be very fast, fluid, and give us a app like experience, right? So client side routing. So when we click, not every time the request will be sent to the server, and not every time for every request the server will return a page, right? For all the client side interactions, only a API call will be made to the backend. The data will be fetched from the server, and depending upon the data, the UI will be built in the client side itself, right? So that is how it makes the fast. So meaning the UI that we are seeing here, not every UI is coming from the server. They are basically built in the client side itself, browser itself, right? Due to the fact that over the period, one thing that has evolved is the infrastructure at the client end, right? If we compare the machines that we were using sometimes back, decades back, and now there is a vast difference. Now we kind of using the machines that once used to be a server, right? So that is how we have evolved. The client side infrastructure is evolved. So now we are leveraging that infrastructure, client side infrastructure, and then we are putting we are actually separating. We are doing some offloading of additional burden from the server to the client end, right? So now the UI building happens in the client itself, right? In a typical single page applications, right? So for every interaction that we are making, only data transfer will be made between client and server, and for that data, depending upon the data, the actual UI what we are seeing, that will be built in the client side itself. That is what we are calling single page applications, meaning an entire application logic is running in the browser itself. A browser is actually loading and executing an application, right? And the browser this time, it communicate with the server, not for the UI but for only the data fetching, right? So I make the request, I go here, I making a request, this, right? I making a request, right? This view is not returned by the server. This view is built by the browser itself. But what is the thing that it received from the server is only the data. So only this corresponding data will be fetched from the server when I click this, and based on the data, the browser is the one that construct the view, right? You can see here. So that is where this doesn't reload, meaning it is not fetching any new UI from the server. So whatever UI changes that I'm seeing here, these UI are actually built in the client, built by the browser, and it is dynamically replaced in the view, right? Dynamically replaced in the view, right? So even though the URL changes here, this URL request is not made to the server, right? So I'm navigating from one URL to another URL, but I'm not navigating the server pages. I'm only navigating between different client views generated by the client. So hence we are calling this navigation, this type of navigation, as client side routing, right? So how to implement this client side routing, right? Simulates page navigation. So this is not an actual page navigation, rather it is actually switching the view, right? The client, within the client side, the JavaScript logic, it's actually switching the view. It is actually removing one view from the browser, and in that place it is replacing it with another view that is built in the client side itself. So that is what we call client side routing. Client side routing is one of the key things that we need to know in terms of single page applications. So what are the key concepts that we need to learn here? One HTML file, logic, client side routing, component based UI. Component based UI is how we can reuse the components, right? So when I say an application, this requires a extensive UI. When we say extensive UI, that will uh, easily increase the code base. So how do I manage the code base? So by creating reusable components, and in this case it is about creating reusable UI components. So how do I build reusable UI components? By using a component based architecture, right? So this is about creating reusable code blocks, right? And then we are saying data fetching, right? So in this aspect, for every request, we mentioned that the client is going to fetch data from the server. So how the data fetch is happening? By using API, right? So the front end is decoupled from the back end, and how the front end communicates with the back end is through API technology, right? Right. A typical illustration of how this works. So this is a conventional websites. For every request, it will return a page. For every request, it will return a page, right? So in the first request, it will return this page. In the second request, it will return a new page. So what will happen? It has to remove this page and it has to load the new page, and hence the reload will happen. Whereas here, for the first request, it will return the HTML document. This HTML doc along with the HTML document, whatever logic that we require, everything will be returned. And for a subsequent request, it only fetches the data. If you can see here, instead of HTML, it says JSON. So it will only returns data, and based on the JSON data, the actual UI will be constructed in the client side itself. Right. So this is a typical characteristics of a SPA. The ultimate objective is to make the application fast, to give the sense of a app instead of website. Right. Right. So primary front end skills, uh, being able to build a simple multi-column layout website and making that multi-column layout website responsive, supporting all devices, and then how to make the fast, app-like applications, single-page applications. So this forms the front-end skills. And what are the frameworks that are associated with single-page applications? For me to build a single-page applications, how I'm going to build, whether only the primary skill is enough, or do I need to learn any other new framework? And that is where we see something called React, Vue, Angular, Svelte, right? We have Next.js. So all these are about building single page applications, right? So we might have heard React is a JavaScript framework, but why it is used? React is the one that is used for building single page applications. So meaning with React as a framework or as a library, it provides support for implementing client side routing, implementing component based UI building. It provides necessary functions or library for making API calls. It provides library for state management, right? All those stuffs, same thing, right? Whatever that I do in React, then how Vue is another framework. So with Vue, we also provide support for client side routing, component based architecture, API driven APIs, I mean functions for providing API calls, and then state management, right? React, Vue, Angular is a next thing in terms of front end layer, right? So how do I do data fetching? There is something called Axios, Fetch API, state management. I have Redux, right? And for PWA, progressive web app, we have service workers. So PWA in the sense, even without internet, now my application has to function, right? So a typical website will not work if there is no internet. But even without internet, my application has to work. So how do I make it? By using something called PWA, right? Progressive web applications, right? Right. So we have covered all aspects of the front end, primary front end skills, responsive web design, single page applications, and for each of these things, we are also mentioned the associated tools and technology that we can pick up. Right. So when it comes to primary thing, it is about the primary logic, primary technologies. For responsive, it is primarily about Tailwind and Bootstrap, and for single page application, it is about these JavaScript frameworks like React, Vue, or Angular, and then we'll go to backend. So backend is the server side logic, right? So the core business logic that forms the backend, right? So what is a languages that what is the technology used here? So we use any of these popular languages for build a backend. So either we can use Python or Go or Java, PHP, Node.js, whatever it is, right? So we can choose to go with any of these languages for us to build a backend logic, right? So these are the popular languages, and top frameworks that we have is when it comes to Java, we have something called Spring Boot. For Node.js, we have something called Express or Next.js. For Python, we have Django or Fast API. So these are the frameworks that helps in building this backend application much more faster, right? So this provides libraries, tools, connectors, whatever it is. So this basically framework helps us in managing the non-functional aspect of the application, where we can focus more on the primary logic and then can build the application much more easily and faster, right? So the core business logic is forms the backend, and how I can get to implement the core business logic is through the languages. And in addition to the languages, we can use framework in order to make the applications in order to build the backend much more efficiently and fastly, right? So key responsibilities. What are the key responsibility of the backend? It primarily need to manage the data processing and storage, authentication and security, business logic execution, and then serving data to the front end. So this basically, as a backend, it has to manage all these things, and at the end, it has to serve the data to the front end, right? Right, how the backend is getting connected with the front end, right? So how the backend is getting connected with the front end. So now we know what is backend and what are the core technology that forms the backend. Now we move to a medium that connects front end with the backend, which is the API medium, the middleware medium, right? So one of the foundational thing that comes to API is REST, right? REST stands for representational state transfer. This is a foundational principle that we need to know for us to implement the API medium, right? So what are the core principles of REST? It is client server, right? Stateless, meaning the server will should not store any informations about client. It should have a cacheable and then uniform interface, right? Meaning it has to use the URLs, right? For data, for how the backend is exposed, backend is exposed via URIs, right? Right. So as a front end, how it can communicate with the backend through URLs, right? That is what REST is about, right? When we say API, one of the primary API technology is REST, right? So in REST, how a front end will communicate with the backend? So the front end will communicate with the backend through URIs, uniform resource identifiers, right? How the front end will tell what it needs to do with the backend, whether it wants to fetch the data, whether it want to create a new data in the server, whether it want to modify data in the server, whether it want to delete a data in the server, how it will tell? It will tell using HTTP methods. This is what REST is about, right? REST actually stands for representational state transfer. It has a set of architectural constraints, and based on these architectural constraints, if a backend is developed, then the backend is called as a REST API, right? So what are the tools that are there to test REST? So we have something called Postman, we have Swagger, and then Open API specification for us to build the REST API, right? So we need to build the backend as a REST API. So that is the second thing. So I know how to build front end, right? I know how to build front end. My front end has to be a responsive UI or a single page application. Now what kind of backend that I need to build? I need to build a backend. I need to build a backend using this technology, and then I need to expose that backend, right? So it is not only about building the backend, it is about making the backend suitable to be communicate with the front end. At the end of the day, the front end needs to communicate with the backend. How do I make the front end to communicate with the backend? I need to expose this, right? And what is that thing that I use? I need to use a API technology to expose my backend. And one of the foundational API technology that we have is API. So I typically need to build my backend as a REST API. So this is a second. This is a next milestone in our full stack web development. So we need to build our front end as a single page application. we need to build our front end as a single page application, and then we need to build our back end using any of this framework. You can choose to go with Express, or you can choose to go with Django, or you can choose to go with Spring Boot. These are different tracks that can be used for building a backend, right? So I can build my front end as a SPA, and then I need to build my backend as a REST API, right? So I built using Spring Boot, and then expose it as a REST API, right? So now what is REST is the only technology for the API. So what about other technology, right? So you have another technology called GraphQL. So either I can expose my backend as a REST, or I can expose my backend as a GraphQL, right? So how GraphQL differ from REST? REST is only about primary principles, right? So REST is only about primary principles. What about much more high level principles? For instance, querying the data, right? Which is about querying the data. So if I want to deal with my data in a much more high level, then you have something called GraphQL, right? So for instance, SQL, right? If you take SQL as an example, the way we do data processing is through an high level way, a declarative way, by using SQL queries, right? I don't need to write any function, or I don't need to write any complex logic for me to process the data that is stored in a SQL database. So what is the interface that I have is something called SQL. So with SQL, through a declarative approach, I'll be able to manage the data stored in the database. And similarly, I can work with my data that is handled by the backend in a declarative way through GraphQL, right? So depending upon our requirement, we can choose to go with either REST or GraphQL, right? So as you can see, GraphQL is a query language, and the servers are runtime for API. It prioritizes giving clients the power to request the exact data they need, right? So with REST, we have something called overfetching. So like I mentioned here, I cannot query the data, right? Here I cannot query the data. If querying data is one of a concern, then I'll go with the GraphQL. So these are the two widely or famous API technology that we can choose to use for us to expose my backend. So I build my backend. I'll either expose it as a REST API, or I'll either expose it as a GraphQL. So before the um, mm, REST or GraphQL, what we used to do something called in terms of SEO, like someone mentioned, service-oriented architecture. So we used to have something called SOAP services, right? Simple Object Access Protocol, right? So things have evolved from SOAP to REST, right? Things have evolved from SOAP to REST. Now we have something called GraphQL, and then there are other API technology, right? So we have Socket, we have right. Right. So you can also explore other web technology, right? So these are the two, I mean, API technology. These are the two primary API technology, and there are other API technology, or we can even use a tool to do that. So that is where the things like Kafka or RabbitMQ that will be coming into picture, right? So how are we going to manage the communication between the applications? Either it might be between the front end and the back end, or it might be between multiple backend services. How are we going to manage the communications, right? Through REST or GraphQL, or through Kafka, or through RabbitMQ, or through some other asynchronous communication uh, protocols, right? Right. Then now we are dealing with the actual data, right? Or now we are dealing with actual data. So front end is done, back end is done. How the front end is going to speak with the back end, that is where we have API, and then as part of API we have we saw two primary technology. One is REST, and the other one is GraphQL. Now the actual the data itself, how are we going to manage the data, or what are the modern tools available for managing the data, right? So we know what is database is how we store the data in a structured way. There are different types of databases. One is relational database, and then the other one is non-relational databases. We call it as NoSQL, right? So here what are the key things that we need to pick up is the data modeling, and then the ORM, object relation mapping, when it comes to relational databases, right? ORM, object relation mapping. right? So relation is how we manage the data in the database. Object is how we manage the data. We represent the data rather in the program. So in a program, we represent the data as an object. In the database, we represent the same data as a relation, right? So naturally, they won't go well together. There will be a lot of mismatching. How are we going to sort out this mismatching? That is called object relation mapping. So if you want to manually do this mapping, then it will be time consuming, right? So how are we going to do this? It's by using the ORM frameworks, object relation mapping frameworks. So now this is where things like Hibernate, IBAT is that will be uh, that will play a key role, right? So in terms of databases, on top of learning the actual database like the SQL databases such as Postgres or MySQL, or in terms of NoSQL, we have something called MongoDB, Redis, DynamoDB, stuff like that. On top of learning the actual databases, one of the important thing that we need to learn is something called ORM as well, right? Object relation mapping, right? So what are the modern trends? Serverless databases, edge caching. This is to increase the efficiency in accessing the data. So a database access is always going to be costly. Depending upon the query that we are going to execute, it has to fetch data from multiple tables or multiple collections. So it is going to be costly. Every time a data is fetched from the database, it is going to take some time, and ultimately it will play a key role in the efficiency of the application itself. If it is going to take more time in fetching data from the database, the application is also going to very slow, and if it is taking even more time, the application will eventually stall, right? So how do we mitigate this? It is by using proper caching, right? So edge caching, modern trends is about serverless databases. So here we are not going to deal with how are we going to deploy the database. So here I am going to deal with a database that is readily deployed with enough connections required for my applications. So that is where we call it as serverless database, right? With serverless database, we don't actually worry about how the database is getting configured and deployed. So all we need is a database is there, and the underlying infrastructure is managed by the database provider, the cloud provider. The only thing that I need is how to connect with the database. Everything else will be managed by the database provider itself, what we call as a serverless database, right? So this will save time in terms of database management. And that how do we make the application more efficient is by using proper edge caching and then vector databases, right? So vector databases, with these vector databases are essential for AI and semantic search. These are the modern trends. Since now since it is a world of AI, so these vector databases are getting more visibility, right? So in terms of databases, we need to have the basic understanding of what exactly is databases, what is the different types of databases, or what are the two categories of database. One is relational, the other one is non-relational. So relational, it follows a fixed schema, whereas non-relational databases, this doesn't follow a fixed schema, right? So here not necessarily data will be stored as rows and tables. So here data is stored as rows and tables. Here it is not necessarily rows and tables. It can be objects, it can be documents, it can be JSON key value pair, something like that, right? So based on our requirement, we can choose to go with either relational or non-relational, right? Right, so type of modern databases. So these are the different types of databases. We have relational databases, document databases, key value databases. Right. So all these databases, apart from relational databases, they will be falling under NoSQL databases. Right. So these are some of the examples: PostgreSQL, MySQL. For document database, we have MongoDB, Couchbase. For key values, we have Redis, DynamoDB, and then Postgre or MySQL both falls under relational will be best for structured data and transactions, right? So if the data that we are dealing with that is more critical data, where the security is of more important, then we can go with the relational, all right? So if you want to have a flexible schema, then we need to go with a NoSQL database, right? Right. So for instance, when it comes to social network, it is about relationships, right? So when it comes to data related to social networks, so we have friends of friends, right? Friends of non-friends, something like that. So it is about relationships. So how do I represent the relationship, or how do I store the relationships much more efficiently? So I need a graph database, right? So that is where I use Neo4j. So depending upon the requirement, I can get to choose a appropriate database, right? So choosing a right database is important, is one of a key consideration in building a full stack application, right? Right. So what are the key considerations? We need to see whether the database is scalable, right? We need to consider whether these consistencies of key importance or not. How are we going to query the data stored in the database? Schema, whether it is having a fixed schema or a flexible schema, right? What is going to be the latency, and then the cloud native features, whether it comes with a serverless or I manually need to manage the deployment, whether it can be deployed in any region, something like that, stuff like that. So these are the key considerations based on which we need to choose a database for our application, right? So front end, back end, API, and then database, right? So front end is the UI, back end is the back end logic. How front end is going to get connected with the back end is the API logic. Where the actual data is going to get stored is the database. So across all these layers, we also saw the corresponding tools and technology that we can choose to use, right? Right. Now, what are the other stuffs? So how are we going to manage the source code, right? How are we going to manage the source code? Like I mentioned, there are going to be multiple, if a particular team is working on a project, there are going to be multiple developers who are going to work with the projects, and not just developers. The source code is going to get accessed by other people as well, like testers for testing, right? So we need a common location where we need to manage the source code. We need to track all changes, and then we need this has to be available in multiple. This has to be deployed in multiple platforms, in production, in testing, in staging, in client, everything else. How are we going to manage these things? That is where we have operations, development operations. So bridging the development and operations for more reliable software delivery, right? So DevOps and source code is about managing the source code itself. It's about managing the application source code itself, right? So what are the core concepts involved in DevOps and source code? Version control. So we need to keep track of all changes, whatever changes that are being done in the source code, right? Continuous integration and then continuous delivery, right? So here it is about automating the code change. How are we going to integrate new code with the source code, right? How fast we are going to do it. So there is a process, right? So whenever a new code is getting added, we need to run the corresponding test, right? Usually the test are executed in schedules, right? So usually in the weekend or in the mid of the weekdays. So we used to schedule the running of the test cases, right? So how these things are getting automated for continuously integrating a new code with the existing code, right? So there might be multiple developers. Every developer has to work in the same code base, right? How I ensure that code that is being developed by one developer is getting accessed by another developer, and there is no conflicts, right? And at any time you should be able to navigate to a old code that is getting that is working in case if any of the new code has broken the application, stuff like that. So these are the core concepts that manages this, right? And what are the key tools? Git. The other one is Docker and Kubernetes, right? So here this is about version control, CI/CD, and then deployment, right? Right. So right now Git is the front runner in terms of SCM, source code management. So in terms of source code management, Git is a front runner, meaning Git is a de facto tool for source code management. Even though we have multiple other tools, still Git stand out, right? So what does that mean? So anyone who is picking up full stack development skill, we can actually choose to go with either front end or back end, right? But we cannot have an option when it comes to Git, right? So everyone has to know Git, right? Right. So that is what it is. So Git has become a de facto tool for source code management. Right. So Git stands for Git is actually a tool. It is a distributed version control tool used for track changes in software development. Right. So it allows multiple developers to work together on a non-linear development. Right. So what are the fundamental concepts? How I manage a Git repository? Manage the sense I should be able to create, modify, move the Git repositories, right? Move the Git repositories. I need to commit my changes. I should be able to create and manage multiple branches, and I should be able to, merge the multiple branches, right? So these are the essential Git commands. Right, and now what about deployment? How I'm going to deploy? So like I mentioned, my application has to run in multiple environment. So typically in a developer environment, in a testing environment, in a staging environment, right, or in a client environment, right? So how I'm going to make my application work seamlessly across all this environment? For instance, there will be cases an application that is running in one machine will not be working properly in another machine, right? Will not be working properly in another machine. So because of the different factors, so dependencies are one factors, version is one factor. For instance, in my machine I'm having Windows, maybe in another machine they might be having a different operating system, right? Or even though both are using Windows, they might be using a different version of Windows. They might be having different sets of libraries that are not relevant to the one that I'm having. So there will be a lot of mismatch in terms of environment in which the application has to get deployed. So how do we get managed? How do we manage these things seamlessly? So that is where we have something called containerization. Through containerization, we distribute our application as containers. So once we are building our front end application, once we are building our back end application, how I am going to distribute my front end? How I am going to distribute my back end? I need to distribute my front end and back end as Docker container. Right. So Docker is a containerization tool where it will allow us to bundle my application along with its dependency as an isolated unit, right? As an isolated unit. So Docker is actually a tool for containerization. So containerization is a process of bundling our application along with this dependency as an isolated unit called containers, right? As an isolated unit as containers. So on top of front end skill and then back end skill, we should be able to containerize our application. So that is the next skill. Containerize our applications. Now, I have multiple applications. In a typical microservice architecture, I have multiple applications. So I need to have multiple containers. I'll be having multiple containers. How do I manage the multiple containers? Or even if the application is single, even if it is a single applications, I need to have multiple instances of the same applications in order to handle the load, right? In order to handle the load. So if there are multiple requests coming, I need to increase the instance. If I have few requests coming, then I need to have couple of instance, right? The same product service I need to run 10 product service or one product service or two product service, something like that. So I need to have scaling, proper scaling. How do I manage the, meaning I need to increase or decrease the number of containers, product service containers or user service containers, something like that. So I need to have n user service container, n 10 user service containers or one or two or three user service containers. How do I do this? So that is where I use Kubernetes. So Kubernetes is used for managing the containers, right? So it is used for managing the containers or container orchestration, right? Because here scaling and management, right? So on top of Docker, once you are I mean we are able to build front end and then I'm able to build back end. Now it is about how I'm going to distribute in such a way it should be running properly in all environment. So instead of distributing the application alone, I'm bundling the application as a container and then I'm distributing the container. That is where we use Docker. Now how do I manage multiple such containers is by using Kubernetes, right? So in our full stack track, after front end, back end databases, source code management, the next key primary thing is containerization and managing the containers, Docker and Kubernetes. Right, now the security, right? So how are we going to rather, right? So now I'm building the containers, deployment strategies, how I'm going to deploy, where I'm going to deploy, whether I'm going to deploy in virtual machines or whether I'm going to have any other options. So typically it is going to be cloud. Typically it is going to be cloud. So these are the several options. So traditional options are private servers or cloud virtual machines or the container servers itself. So we have container services itself, right? So we have something called Vercel, Netflix, AWS Lambda, Cloudflare. So these are actually the cloud providers. So here the key clarity that we need to have is that what is the support that they provide for us to deploy a container. So that is what is the clarity that we need to get. So now that I have my application built as a Docker container, so how I am going to deploy this container? So I need to look for appropriate services provided by these cloud providers, right? Right, security, right? So three core pillars of security: confidentiality, integrity, and availability. Right. So we need to keep the data private. It should. I mean, we need to ensure only authorized people are getting access to the data. Integrity, ensuring that the data is correct, not tampered, and then availability. Whenever the data is wanted by the authorized person, it should be available. Right. So what are the key practices? Secure coding standards, dependency scanning, regular security audits, principle of least privilege. What does that mean? Principle of least privilege. So we should provide access only the least access that is required. Right. So we should not provide all access at the same time. You should only provide the least access. Right. So when it comes to security, there are two things. One is authentication and authorization. Right. So for how do you perform authentication? So authentication is how we tell who you are. Right. So how do I do it? Core concepts, sessions, tokens. OAuth 2.0. OAuth 2.0 is a standard for the tokens, single sign-on, and then multi-factor authentication. So these are the core concepts that we need to cover. And what are the tools, relevant tools that we can use to implement these things? We have something called JSON Web Tokens for token, right? And then OAuth 2.0, right? OAuth 2.0 and then OpenID Connect, right? We have Auth0 and then Firebase authentication. So these are the tools that we have. And then on the other hand, authorization, again, what are the core concepts? We have RBAC, role-based access controls, attribute-based access controls, right? So this is primarily uh, providing permissions based on the roles, and this is about uh, the resource, right? What forms the authorization? API scopes, API gateways, input validations, and then OAuth principles, right? So when it comes to security, two things, right? So one is JWT and then OAuth 2.0, 2.0 OpenID Connect. So there are several playgrounds that you can find online where you can test this authorization process. Right, so these are actually the authorization mechanism. When I say OAuth 2.0, this is the authorization mechanism. Ideally, whatever web application that we are doing online, they are all integrated with OAuth 2.0, right? So for instance, wherever I go, I can see options like login via Gmail or login via GitHub, something like that. So any third-party websites that I go right now, they have an option to use my Google account, right, or to use my GitHub account, something like that. For instance, if I want to open an account in Facebook, I don't need to manually key in my informations. I can use my Google account itself to log into my Facebook, right? So how that is happening is a concept called WAS 2.0, right? So the primary thing that we need to um, pick here is two things. One is JWT, the other one is OAuth 2.0. And OAuth 2.0 is having different uh, process. OpenID Connect is one thing, right? And OAuth 2.0 is also have different variations, right? Right. So testing is an important aspect when it comes to a full stack development, right? So if you are a normal front end developer or a back end developer, this is not going to be a key consideration. But when it comes to a full stack skill, testing forms a key skill. So it is also equally important for us to have the skill of testing, right? So so how do I what kind of test that I need to do? So I should be, as a full stack developer, I should be able to do unit test, integration test, and then end to end test. And on top of able to do these tests, I should also be able to automate this test, right? So meaning I should be able to work with test automation tools and frameworks such as Selenium, Cypress, or Playwright, something like that, right? So like I mentioned, full stack development is about everything. That includes testing as well, right? So how do I perform CI/CD? Right, so these are the tools. So I have GitHub Actions, I have Jenkins Circle CI. So these are the tools, some of the tools that I can use to implement continuous integration or continuous delivery. So like I mentioned, continuous integration is about automatically integrating new code with the existing code base, right? So how do you actually get to automate this, right? I need to automatically run the test cases, write test cases at the right time, right? How do I autonomously manage it? So I can use this tools, right? GitHub Actions, Jenkins, right? Right, right. So what are the other steps? So like I mentioned, how this is going to how this is going to play a role, how these FSD skills are going to play a key role in AI, right? So these are the next steps. How AI is revolutionized in coding. So how exactly we can use AI tools in coding, right? So as you can see, you have something called code generation, bug detection, right? Agentic AI is something and another parallel that we can explore. So for all these things, the thing is the front end skill, right? So without FSC skill, we won't be able to work with something called agentic AI programming, right? Um, Agentic AI, and then one of the trending thing that is going around is something called vibe coding, right? So we've been hearing something called Replit, we have something called Cursor, um, stuff like that, right? What exactly is vibe coding, right? So we are speaking about no code, right? Now we have evolved from no code to something called vibe coding. What exactly it is, right? So agentic AI and the vibe coding is something that is seen as a threat to the developers, right? So in recent days, so we say that no developers, there will be no developers, right? So what is the key thing that keeps the talk is something called vibe coding and then the agentic AI, right? So going forward, it is the talk is about all the developers will be replaced by AI agents, right? Most of the job roles will be replaced by AI agents. What exactly it is, right? And what exactly is vibe coding and why full stack skill is still matter in the AI of era. So even though we are saying agent AI and even though when we say vibe coding, how full stack skills are still relevant and still a necessity for everyone in order to cope up with AI, right? Stuff like that. And then what is serverless? We already have a small glimpse on what is serverless. Now this is about only managing the functions. Underlying infrastructure will be managed by the provider itself. So this serverless will be applied for all the areas. So what are the serverless feature available for front end? What are the serverless feature available for backend, API, databases, containers? So serverless has evolved a lot. So initially when we say serverless, it only it refers to a logic. We call it as lambdas or serverless functions. Now from that point, it has evolved to serverless front ends, serverless containers, serverless backend, right? To a lot of stuff. Serverless databases, right? So whatever tools that we use, they're all coming as serverless. So what exactly it is, right? So as we say AI, the serverless also plays a equal role. It's also a trending thing like AI serverless, right? Where the infrastructure is managed by the provider itself, right? So how the serverless got evolved? What are the different serverless technology? Right, modern serverless platforms, right? Roadmap to mastery. So this is what we are saying, right? Foundations, front-end framework, backend DB. So I'm just giving a overview of what this full stack development course is about, right? Just giving you a highlight. This will be covered comprehensive in our full stack development course. Like I mentioned, this masterclass is about giving a overview on all such things that we are going to cover in our full stack development program, right? So hence I'm taking it fast, right? Toolchain map. Here I try to provide exhaustive things that we are actually covering in our full stack development program. How you can endorse your learning is by building a actual AI agent with any of this tech stack, right? And these things, right? Right. So, like I mentioned, this 1 hour masterclass is about giving you a overview on different tools and technology and skills involved in different layers of different aspect of full stack development, right? So, like I mentioned, this helps us to build a roadmap for our learning, right, and also acts as an introduction for the skills that we are actually covering in our full stack development program, right? I hope this session would be a helpful session for for you to get introduced to some of these tools and skills, and thanks for joining in. Right. In case if you want to know about any of these things, you can probably reach out to us. You can visit our website and then enroll for our courses. Thanks for joining in.
Yeah, I have one question.
Yep.
So, if you have to join this course, can you inform how many days and then the schedule if it is available, so that we know how much time it will take for these courses?
Yeah, sure. I think I'll ask my admin to get in touch with you. Probably the informations are there in our website, so you can reach. You can go to garantoacademy.com.my. So here in the landing page itself, you can find about all our courses. So
Okay.
under
We do have also the Singapore website, sir.
yeah.
We will inform you for the next schedule, sir, and then
Yeah.
we'll share all the schedule, our upcoming schedule, sir.
Okay.
Yeah. So you can search in our Malaysia site. In our search bar, you can say full stack, and then you will find it. And then you can also visit our Singapore site as well, like Gigi mentioned.
Yeah. Thank you.
Yeah.
And thanks a lot. It's an excellent overview. Thank you.
Yeah. Thanks, Surya Narayanan.